Chapter 5.3 Applications of Electromagnetic Induction. Part 1 Generators. Generators are devices that can turn kinetic energy into electrical energy. The setups of question 20 and 22 on page 274 are examples. And yes, a generator can be as simple as a solenoid and a magnet only. So you see that a generator must make use of electromagnetic induction to convert mechanical energy to electrical energy. A. Induced EMF and current in a rotating coil. When the coil rotates inside a magnetic field, an EMF is induced. Let's take a look at the following simulation. A coil is rotated inside a magnetic field. Current is induced. Let's do it again. At the beginning, you can see that the current flows in this direction, from the top left into the plane, to the bottom right, out of the plane. When the plane of the coil becomes vertical, there's no induced current. When the rotation continues, you can see that the current is induced in this way from the top right, out of the plane, to the bottom left, into the plane. When the coil in its horizontal position is started to rotate, the sides A, B, and CD cut through the magnetic flux, and hence EMFs are induced. According to the Feynman-Slattery rule, the two induced EMF flow in the same direction, and hence the two sides act like two dry cells in series. The induced current flows from right to left through the ammeter. When the plane of the coil is vertical, there is no induced EMF and hence no induced current. When the coil continues to turn, the induced EMF on CD and AB produces a current that flows from left to right through the ammeter, and hence an alternating current is induced. Similar to the structure of an electric motor, we need to use a commutator to produce direct current, or use a pair of slip rings to produce an alternating current to the external circuit. B. Simple AC generator. In a simple AC generator, a pair of slip rings rotates with the coil and connect with the carbon brushes and external circuit. The induced EMF and current are maximum when the plane of the coil is parallel to the magnetic field. The induced EMF is minimum when the plane of the coil is vertical. In a generator, the mechanical power given by the external force is converted into electrical power in the circuit. Mathematically, we have Fv equals Vi. To increase the induced EMF and current, there are 5 suggestions here. They all can increase the induced EMF and hence the induced current. Reducing the circuit resistance can increase the induced current, but the induced EMF is not increased. In example 9, the induced current time graph is shown. You are asked to sketch the output when the rotational speed is doubled. You should note that the generator is rotated faster, the frequency increases, and the induced current also increases. In fact, the induced current also doubles when the rotational speed of the coil in the generator is doubled. C. DC generator. A DC generator makes use of a commutator instead of a pair of slip rings. The commutator reverses the connection of the coil with the external circuit every time when the plane of the coil is vertical. And in this way, the current in the external circuit flows in the same direction. The output is a varying direct current, as in figure 5.3h. Note that the induced current is again zero when the plane of the coil is vertical, and attains a maximum when the plane of the coil is horizontal. By the way, the current inside the coil is an AC when the coil is rotated in the same direction. This is true for both AC generator and DC generator. You may refer to figure 5.3c. You can see that the induced current between A and B changes direction every time when the coil is vertical. The Faraday disc is a prototype of DC generator in which a metal disc is rotated between the poles of a pair of magnets. According to famous right-hand rule, an EMF will be induced as shown between the rim and the center of the disc. There is a voltage difference. D. Practical generators. 1. Bicycle dynamo. A bicycle dynamo has a fixed coil and a rotating magnet. A fixed coil avoids frequent connection through a movable contact and hence avoids spark to be produced. 2. Alternators. Large AC generators are also called alternators. They are used in power plant and are driven by a steam turbine. Alternators have rotating magnets, which are electricity powered. Electromagnets may produce very strong magnetic field, and fixed connections of the coil avoid sparks when large current flow through movable contact. Now please do check point 5.